Hello, sir. Welcome to our presentation. Before I begin, let me introduce myself briefly. I am Chaiti Sharkar and my ID is 22202060034. Today I am going to talk about our project. So you can see in the first slide, our project name is Battery Management System BMS Circuit. An overview of components, functionality, and importance. It is a crucial component of contemporary battery technology, especially in uses for lithium-ion batteries. The BMS is in charge of a number of duties, including keeping track of the temperature, voltage, current of each cell in a battery pack. Then here is my group member names. So now let's talk about Introduction to Battery Management System BMS. Definition of BMS. A BMS is an electronic system that manages a rechargeable battery cell or battery pack, monitoring its state, controlling its environment, and balancing its cells. Here is a simple circuit of BMS. The image shows a 4S1P battery pack, which means it consists of 4 cells connected in series 4S and 1 cell connected in parallel 1P. The battery pack has a charging and discharging circuit with connections for charging and discharging. Purpose Purpose of BMS system: to ensure safety, longevity, and efficient operation of the battery. Why is the BMS important? BMS are essential for the best performance of battery packs. They achieve this by performing a number of tasks such as monitoring, protecting, balancing, and reporting. The performance, longevity, and safety of battery system are all granted by each of these functions. Safety prevents overcharging, overdischarging, and overheating. Longevity balances cells to extend battery life. Performance ensures optimal performance by maintaining proper voltage, current, and temperature conditions. Protection guards against potential hazards like short circuit and thermal runaway. So, thank you so much.
Hi, I am Bashir Haq Fahad. My ID is EEE 2202026009 and I am excited to guide you on basic components of a BMS circuit. We will cover key insights and practical tips that you can apply right away. Let's get started. A battery management system BMS is crucial for managing and protecting battery packs, especially in applications like electric vehicles, renewable energy systems, and portable electronics. Below is a brief outline of basic components of a BMS circuit that I used for my presentation. Battery cells, the primary power source managed by the BMS. Sensors monitor temperature, voltage, and current. Microcontroller, the brain of the BMS that processes sensor data and controls the operation. Balancing circuit ensures uniform charge among all battery cells. Communication interface allows data exchange between the BMS and other system. Power supply powers the BMS circuit itself. Now we see diagram of a BMS circuit. Block diagram of a BMS circuit visual representation include a block diagram showing the interconnections between sensors, microcontroller, balancing circuit, and communication interface. Now I explain. A BMS circuit diagram includes a control unit that manages battery cells by monitoring the voltage, current, and temperature, balancing the cells to ensure even charge distribution and providing protections against overcharging, over discharging, and short circuits. It also has communication capabilities to interface with external systems. Thanks for joining me today. I hope.
Hello everyone, my name is Orindi Costa. My ID is 22202026065. Now I am going to share battery monitoring. In battery monitoring, there are three steps. First is voltage monitoring, second is temperature monitoring, and third is current monitoring. In voltage monitoring, each cell's voltage is monitored to prevent overcharging or over discharging. Also, we can say effective voltage monitoring helps to maintain system stability, prevents equipment damage, and ensure reliable operation in various applications, including power supplies, batteries, and electronic devices. In second, temperature monitoring, sensors detect overheating to prevent thermal runaway. And also, effective temperature monitoring helps ensure the reliability and safety of systems, equipment, and environments, prevents overheating, freezing, and related issues. The last one, current monitoring, monitors charge and discharge currents to protect against overcurrent conditions. Also, we can say effective current monitoring is crucial for maintaining the safety, efficiency, and longevity of electrical system and devices. And that's all. Thank you very much.
Thank you, sir, for giving me the slot. This is Rofikul. ID is 22020268080. The group member of group number 3. Together we're gonna present the project of battery management system using MATLAB. The presentation has been divided into 7 parts. In the 5 parts, I'm gonna explain the theory, cell balancing techniques. Cell balancing techniques means used to perform cell balancing, typically include by passing some of the cell during charge by connecting external load parallel to the cell together, controlling corresponding plots. There are two types of cell balancing technique. Number 1, passive balance. Passive balance is excess energy from higher charge cell is displayed as heat. And then active balance. Active balancing transfer excess energy from higher charge cell to lower charge cell, improving efficiency. And then its importance, ensure uniform cell voltage and maximize the battery pack's overall capacity and lifespan. And protection features. Protection feature, there are 4 protection features. Number 1, over voltage protection, shoots down charge when any cell voltage exceeds the safe limit. Number 2, under voltage protection, prevents batteries discharge when voltage drop to low. And then 3, overcurrent protection, limits the current and avoid damage to the cell and circuit. And the last and number 4, protection, temperature protection, triggers cooling machine or disconnects the battery if it overheats. And thank you very much.
Assalamu alaikum. Myself Tanzim Tarbir. I am a student from Shunga University. My ID 888-2020-23-001. Today's topic, communication protocols. CAN bus, commonly used in auto bus BMS for the reliable communication between the BMS and other voice system. SM bus 12C, used in the smaller battery pack for the simpler communication needs. And data lagging, BMS records data for the diagnostic, performance analysis, and the communicate and maintenance.
Hello everyone, my name is Sabik Ahmad. My ID Tripoli 22020202606. Today I am here to talk about a portion of a BMS circuit. We will be exploring real-world application and future trends of BMS. And by the end of this presentation, you will have a better understanding about future of BMS. So let's dive right in and start with real-world application of BMS. Battery management system BMS enhance safety, efficiency and longevity in various applications. In electric vehicle, they monitor battery performance and prevent issues like overheating. In renewable energy storage, they ensure efficient energy use and extend battery life. BMS also manages battery life and safety in consumer electronics. Improves reliability in industrial equipment and provides reliable power for critical medical devices. Overall, BMS is essential for optimizing battery performance across diverse uses. Future battery management system will feature advanced algorithms and AI for better performance. And predictive maintenance. Internet of Things integration will allow real-time monitoring, while innovations in materials and communication will enhance efficiency and interoperability. Additionally, greater focus on sustainability will drive BMS development towards improved battery life and eco-friendly practices. Let's see the workable BMS circuit. Since most of us don't have computer yet, we are decided to simulate this circuit on mobile phone. This is a very basic BMS circuit. In this circuit, we have 3 batteries. The nominal voltage of the battery is 3.7 volt and the maximum voltage of the battery is 4.2 volt. If the battery exceeds 4.2 volt, then our battery will stop taking charge from the source. Let's increase the battery voltage. So we are going to increase our battery to maximum volt 4.2 volt. After increasing the maximum voltage, then our battery stop taking charges from the source. If our battery goes below the maximum voltage, then our battery taking charges from the source. So this is a workable BMS circuit. Thank you for your attention.